Assalamu alaikum. This is Jahangir Sumro, Assistant Professor Electrical Engineering Department, Sakkaraib University. Right now we are going to start our Labview Code 1 uh, Lesson 1 class. Uh, there are totally 10 lessons in Labview Code 1 and this is the first lesson, Lesson 1. In this lesson you will learn how to start navigate Labview. You will learn recognize the main components of the Labview environment and create how to create a new project, how to create a new VI. Basically, in this lesson, you will cover what is Labview software. You will cover what is Project Explorer, how can we use Project Explorer, how many parts of a VI are, and what is the front panel, what is block diagram, what is the difference between a front panel and block diagram, how can you search for controls, VIs, and functions. So these objectives are to be covered in lesson 1. So let's start with what is Labview. Uh, Labview is basically a graphical language. It's a high level language and it's a graphical language. It's not a text based language like C, C++. These are text based languages. Or if you want to access FPGA, you write a code in text based language like Verilog and VHDL. These are also text based languages. But Labview is not a text based language. Labview is a graphical language and it is a platform based approach for measurement and control. So if you want to implement a digital controller or you want to implement an embedded system, you can implement digital controller and embedded system using Labview with a graphical language, and you can directly implement and burn your Labview code into real-time processor and also in an FPGA of National Instruments hardware. So there are a few benefits of Labview software. The one benefit I already highlighted, that it is very difficult to access FPGA by writing code in Verilog and VADL because it takes a lot of time to learn VADL, to learn Verilog. It is a very time taking process, especially power electrical engineering students do not majorly focus on these VADL and Verilog languages, so they get an issue when they want to implement their controller, digital controller embed system in an FPGA. So the other choice is that you can write the code in Labview FPGA and directly load it into an FPGA. So Labview makes it easier for students to access FPGA, and unlike VADL, Verilog, C or C++, this is a graphical language. So the main advantage of Labview is that it interfaces with wide variety of hardware because the software of Labview is also product of National Instruments, and National Instruments itself provides various hardwares like MyRio, like CompactRio, like PXI, like SPRio. In all highlighted hardwares, the architecture is the same. They consist of a real-time processor, hardware consists of a real-time processor and an FPGA. So you can burn your Labview code into either real-time processor or FPGA as per the requirement of your code. So the main advantage is interface with wide variety of hardware. Like MATLAB software, most of the engineering students use MATLAB software, but it does not have good interface with wide variety of hardware. The other advantage of Labview is it scales across different targets and operating systems. You can use it on different operating systems and different targets. And other advantages provide built-in analysis libraries. Labview software has a lot of wide community support available, and it has many express VIs and many built-in analysis library available. Whenever you want to write a project, you may find related project and you can edit as per your requirements to complete the project. So it has wide support available. So now let us start this activity 1. The purpose of this activity is to know that whether you students are aware of this Labview software or not. So in this confidence activity we are going to build a VI, and we are going to calculate the product of two numbers. So let's start this first activity, and if you are very new, then this is just a little activity for you to know how to start a Labview software. So this is my Labview software. I run it. I have Labview 2017 installed in my PC. So okay, now I go to a file and I create a new VI. This is front panel and this is block diagram. I will later on discuss the difference between front panel and block diagram. When you press Ctrl plus T, you are going to get both front panel and block diagram side by side. Okay, so now the requirement is to multiply two numbers. So I go to front panel and select two inputs, interactive inputs. Here I need to get two numeric numbers. So I pick numeric control silver and I further copy it and paste here by simply clicking the control button and dragging with mouse. These are two inputs. I need one interactive output, numeric indicator silver. This is my output. Let's name it A and let us name it B and let us name it output X. Okay, you can align them with this option, align left edges. Align left edges, and you need to go to numeric and select multiply to multiply these two numbers. Connect it with output. So this is how you multiply two numbers. Let us multiply 5 with another number, that is, let us say 3. So when you run it by clicking this run button, you get its product. 5 into 3 is equal to 15. So this is how if you change a number, let us say, let's make it 8, then 8 into 3 will be 24 and this is 24. If you run it continuously, you can see the results. 10 into 3, when you click enter, you get 30. So if you run it continuously, the Labview software will run it continuously, but it can load your processor heavily. So this is not recommended until and unless very necessary. This is from where you stop the simulation or about the execution. Okay. So this was a simple confidence activity in which we created a VI and we learned how to multiply product of two numbers. Okay. Now we discuss about Project Explorer. Now basically projects in Labview consist of VIs, file necessaries for those VIs to run properly, and supplement files such as documentation or related links. So Project Explorer itself consists of Labview files or non-Labview files. So in Project Explorer, you will have your VIs and also the files necessary for that VI to run properly and supplement files and documents related to that VI. So you can use the Project Explorer window to manage projects in Labview. A Labview project is denoted by .lvproj, Labview project. So Project Explorer is where your Labview gets started. So basically, Project Explorer is where all Labview programming starts. And there are some key characteristics of Labview project. You can manage project files using this Project Explorer. Now you see this project is managed by this Project Explorer. It consists of some project files, some VIs, and they are managed by this Project Explorer. And you can deploy programs to remote embedded targets such as NI Compact Rio, MyRio, or any other NI hardware using this Project Explorer. Right now, the project files are under the target of my computer, so the simulations are going to run on the PC. But similarly, the project files can be under the target of any NI hardware other than on my computer, and they can be loaded into NI hardware. So with the help of Project Explorer, you can deploy programs to embedded targets such as NI Compatrio, MyRio, and Crio. And similarly, Project Explorer also helps to create standalone executables and installers for distribution, and it also make it possible to distribute code to developers and create shared libraries. And finally, it can integrate Labview programs with source code control software such as Perforce. So these are different applications of Project Explorer. Okay, so basically, Labview uses many different types of files. In this lesson, you are going to learn three different types of Labview file. One is the Labview project, like this is Labview project, and its name, in the name of this project Explorer is weather station. You can see weather station. So its extension is .lvproj, .Labview project. So one Labview file is .Labview project, another Labview file is virtual instrument .vi. Historically, Labview programs are called virtual instruments or VIs. So we call Labview programs as VI, virtual instruments, because their appearance and operation imitate physical instruments such as oscilloscope and multimeter. Today, Labview VIs can be extremely powerful and sophisticated programs with elegant graphical user interface. So, VI is basically a Labview program file where you write your code, where you write your algorithm. And the third type of Labview file is custom control.ctl, which we will discuss later on. So Labview project can also include non-Labview file types. For example, you can also include documentation files. So Labview can also include .pdf files as well in Project Explorer. So right now I will demonstrate how to create a Project Explorer and how to create a VI. So let's start. I close this VI and don't save. So first you open this Labview software, then you create a project. For now, we are creating a blank project. So click blank project and click finish. This is the project Explorer. So you can also, this is right now untitled. You can save it with some title like file, save. Let's save it somewhere in desktop, let's say in folder altogether. Let's save it with name new project. Okay. Okay, now you should know how to add the VI in this Project Explorer. You can click this My Computer and go to New and create a blank VI. This is how you create a blank VI. And this is the blank VI. This is the front panel. This is block diagram. If you press Ctrl T, you get both visible in front of you. And you can also save it with some name. Let us save this with name of sample VI. So this is how you create a blank VI in Labview Project Explorer. Alright. You can also add existing VI in your My Computer. For adding existing VI that is already created and available on your computer, go to My Computer, go to Add and File. And then say suppose I have a VI file already available. Say suppose this is the file I want to add. This VI file, I can add existing VI file in my Labview Project Explorer. Okay. Also, you can add text file in Labview Project Explorer. Go to My Computer, go to Add, again go to File. Now you see this is a text document, and you can also add text document in Project Explorer because I already mentioned that you can add also non-Labview files in Project Explorer. Double click it, and this is the project. This is the non-Labview file, text file in Labview Project Explorer. Also, you can delete if you want to delete any item in Project Explorer, any VIR non-Labview file. Let us say I want to delete this sample VI from this Project Explorer. Just I click simply delete. So deleting this file from this Project Explorer will not delete it from the computer disk. So I have deleted this sample file from this Project Explorer, but it should be available on my disk. Let me show you this one. You see this sample file is available on the disk, but you delete it from the Project Explorer. So should be clear that deleting anything from Project Explorer tab does not mean that you delete it from disk. Alright. So next thing that we are going to discuss is how to add folders to your project. There are basically two types of folders. One is the virtual folder and other is the auto-populating folder. So let us differentiate between a virtual folder and auto-populating folder. Basically, an auto-populating folder is a synchronized to a folder on a disk and constantly updates or populates to reflect the contents of the folder on disk. So basically, when you add an auto-populating folder to a Project Explorer, it means that you add it directly on disk to the project. Whatever change you make in the project, that changes are saved in the memory of the disk. So adding an auto-populated folder to a Labview project effectively adds a directory on disk along with its subdirectories. So Labview continuously monitors and updates the auto-populating Labview project folder according to changes made on disk and changes made in the projects. This is not the case with the virtual folder. Virtual folder, though it organizes the project, but it does not represent files on the disk. So virtual folder has no folder in the disk, but it's basically a virtual folder. However, you can also convert a virtual folder into auto populating folder, and you can also convert auto populating folder to a virtual folder. So let me demonstrate how do we create a virtual folder and how do we create auto populating folder in Labview. Right now, let us say I create my computer and I create an auto populating folder. So here I let us say create an auto populating folder with name sample. So this is auto populating folder, and you see this symbol. This is the symbol of auto populating folder, right? Let me show you from here as well. So these are custom controls and displays auto populating folders. So this icon represents auto populating folder, whereas these two are the virtual folders. So as you notice that when I created an auto populating folder, then I created a folder on a disk, on my computer disk. I can also add VIs to my auto populating folder. For example, I add a VI to sample. I go to new, I create VI, and let us say I save this VI with any name, say suppose test. So now this auto populating folder consists of a simple VI that I right now created, a blank VI. Similarly, user can also create a virtual folder. A virtual folder does not represent files on disk. So simply you click my computer, new, and virtual folder. So this is your virtual folder. Let us name sample virtual folder. This is virtual folder. Let us say we call it VF. So basically, this is a virtual folder and this is the auto-populating folder. It has memory on the disk. This does not have memory on the disk. Similarly, you can add VIs and manage VIs in virtual folder as well. Go to right click it and create new VI. Go to file and go to save, and you can create any blank VI. Let's call it test22, and this is a file, and this is a file in, sorry, I save it outside the this folder, and let's call it virtual vi, or you can name it any other name. So you see this is the vi that you created in virtual folder. So this is the difference between an auto populating folder and virtual folder. Now I will show how can you make auto populating folder to a virtual folder. Simply right click it and click stop auto populating. When you click stop auto populating, your this auto populating folder will become a virtual folder, and you when you click this again and you want to convert this virtual folder to auto populating folder, similarly you can also do it. So this is how you change a virtual folder to an auto populating folder. Okay, so right now we discussed the difference between a virtual folder and auto populating folder. So the main difference is that auto populating folder has memory on the disk, and it adds a directory on disk to the project and continuously monitors and updates the folder, whereas virtual folder you can organize the project but it does not represent files on disk. Alright, so now we are going to discuss parts of a VI, virtual instrument. Okay, there are three parts of a VI. One is a front panel, another is the block diagram, and third one is the icon connector pane. We would we would differentiate, recognize the difference between front panel and block diagram, and we would also understand what is icon and connector pane. So this is the front panel. Front panel is where you see your interactive inputs and interactive outputs, and block diagram is where you write the algorithm and logic of your code. And this third one is the icon or connector pane. You see that these are two inputs and these are two outputs, and simply you are adding two numbers and subtracting two numbers. So these two numbers can be mapped to this connector pen. This is connector pen, and connector pen is used to map the inputs and outputs. These are two inputs represented here, and these are two outputs represented here. And this one is the icon. This one is the icon. Icon consists of a picture. Picture or symbolic form of the VI. Like it consists of one add symbol and one subtract symbol to show the user that this VI has the operation related to addition and subtraction. So this icon represents the graphical pictorial representation of your VI. So uh, one is the front panel where you see your inputs and outputs, and one is the block diagram where you write the code. Third is the icon and connector pin, and basically this icon and connector pin is also used when you want to convert a VI into a sub VI. Let me demonstrate this. I close this project, I don't save. So core 1, I go to exercise, I go to demonstration, and I open parts of a VI. Parts of a VI, and I open this Labview project, parts of a VI, and I open this. You should always remember that we always open Labview project, and after opening the Labview project, then we open the VI. This is a recommended approach of National Instruments. Now I open this add in sub VI. Now this is the front panel. Now you see, front panel is used to display inputs, to display outputs. These inputs in Labview language is called control, and these outputs in Labview language are called indicators. So the front panel shows controls, shows indicators, are simply inputs and outputs. And this is the connector pen. Connector pen basically map consists of map of the inputs and outputs of a VI, and this icon is a graphical representation of a VI. Suppose I double click it, I get this input. So it shows that this input is mapped with here, and if I double click it, it shows this input. It shows okay, I mapped two inputs and I mapped these two outputs using the connector pen. Okay, all right. When I press Control E, I get block diagram of this VI. So it shows two inputs. If I double click it, I will go to the front panel and it show me the input. Alright. So this block diagram is where you write your code. What I have done, I have added these two numbers, and simply these two numbers are divided, and these are the outputs that we are getting. So right now we understood that a VI, which is basically a Labview project, which is basically a Labview file to write your code, consists of three main parts. One is the front panel, and this is the front panel. Other is the block diagram where you write the code. The third is icon or connector pen. So let's move ahead. Now we will discuss in detail about front panel. Uh, and we will understand components and functionality of front panel window, and how to select appropriate controls and indicators. And we will discuss about front panel window toolbar, control and indicators, string, boolean and numeric data types, and finally front panel object styles. So this is basically front panel window toolbar. You see this red highlighted one is the front panel window toolbar. Let me show you in Labview front panel file. So this is the front panel, and this is called front panel window toolbar. This is run button. If you want to run your simulation, you will click this run button, and this is run continuously. If you want to continuously run your simulation, you will hit this run continuously button. But this can heavily load your processor and is not recommended until and unless very necessary. And this is abort execution. This is used to stop your simulation, abort your simulation, and this is pass. This is used to pass your simulation pass button, and this is your basically text setting option available, and this is for aligning the objects. Say suppose I want to align these objects to left edges or right edges, you can align these objects, and this is for distribute objects, and this is for resize objects. This is to reorder the objects. This is the search button where you can search uh, you can search the inputs and outputs and other functions as well, and this is your icon and connector pane as discussed, and this is your simply help button. All right, so this was all about front panel window toolbar. Okay, so as discussed that front panel is used to select inputs and outputs. Inputs are called controls. In Labview, inputs are called controls, and in Labview language, outputs are called indicators. So front panel is used to pick up controls and indicators. Okay, right now you are seeing this front panel, and if you see this number of measurements is used to enter some number of measurements, so this is input, and in Labview we call it control, and this is also input where you can give delay multiplier, you can add some delay, you can multiply some delay multiplier, you can change this value, and this is also control or this is also input. This temperature chart, you can see that this temperature chart will show some temperature. So this is basically output, and in Labview language we called it indicator. This stop button, when you will click this stop button, this front panel, this simulation will stop. So this is also control or input. So in Labview you have controls and indicators. Controls are inputs and indicators are outputs. Some other inputs can be knobs, buttons, slides, and some other indicators or outputs can be graphs, LEDs. So control basically supply data to the block diagram. So you supply data to the block diagram by using controls. And indicators display the data the block diagram acquires or generate. So whatever data block diagram acquires or generate, you can see it with the help of indicators. All right. So now uh, Labview consists of different data types. Like first we discuss about control that are called input interactive inputs, and we discussed about indicators that are called interactive outputs. So Labview consists of different data types. One data type, like other languages, Labview has data types. One data type is Boolean. Boolean, the Boolean data type represents data that only has two possible states, such as true and false, or on or off. Use Boolean control indicators to enter and display Boolean values. So if you click this push button, this will be push button will be on. If you remove the click from this push button, this can be turned off. Similarly, this LED will show that whether it is on or off. So it will consist of any two states, either on or off, one or zero. So this is Boolean data type. This is Boolean control, and this is Boolean indicator. And other uh, data type is string. String data type is the sequence of ASCII characters. Use string controls to receive text from the user, such as password or username. Use string indicators to display text to the users. So when you want to log in username or password, or you want to write something in ASCII characters, so you use this string data type. So string data type is to used to enter some text. Okay, some ASCII characters. All right. The third data type is numeric data type. So numeric data type can represent number of various types such as integer or real numbers. The two common numeric objects are the numeric control. This is numeric control to enter some numeric number. It can be of any data type like I32, I64, or it can be like integer value, or it can be unsigned value like U32, U8, U16, and this is this is numeric indicator, and similarly it can be U32, U8, U16, or I32, I16. This can be of various uh, 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 size. So these are different data types that you are going to use, and you are going to select in front panel. All right. So now we will perform an activity to select front panel objects. For each scenario, determine the appropriate data type and whether the front panel object should be a control or indicator. So basically, you should be very much clear now about front panel, that in front panel you select control and indicators. Now we would create a scenario where I will ask from you that which option is best for selecting the front panel objects. So like display the temperature of a room. You want to display the temperature of a room. Certainly data type should be numeric, and it should be indicator because it is displaying, and whenever you want to display it should be indicator or it should be iterative output. And temperature will be certainly a number like 26 centigrade or 28 centigrade, so it should be a numeric. Similarly, uh, what will be uh, data type, and will it be control or indicator for the remaining three options? Let us see. An emergency stop button to stop a process. You want to stop a process, it should be an emergency stop button. Certainly, it should be control because user will decide okay, whether it should stop the process or not. So an emergency stop button should be a control, and it should be a Boolean because either on or off. Let's come to third option, username and password to log into your bank account. So this should be uh, control. Certainly it should be control because user has to enter its name and password. So control, it should be control here. And data type should be string because it consists of ASCII characters. Now let us come to last option, an LED to display error status. So it is an LED, it's displaying something, so it should be indicator here. So it's not a control, but it's a indicator, and it will be a boolean because LED will be either on or off. It has two states, so it will be a boolean. So up to now we discussed about front panel, and why do we use front panel. We discuss about front panel window toolbar, we discuss about control and indicators, and we discuss about three types of data types like string, boolean, and numeric data type in Labview. All right. So front panel object styles. In front panel, you will get four different front panel object styles. One is modern controls, another is the system controls, third is the silver controls, fourth is the classic controls. So you can use any of the front panel object styles. It must be clear that all these different four object styles have same functionality, have same working, but only its physics is varying, only its look is different. Otherwise, functionality of all these four palettes is going to remain same. The control indicators on the silver palette are the newest to the Labview. They provide a rich user interface because of the added glyphs. The silver projects tend to be a little larger than other styles. So the uh, recommended front panel object style is silver. Still, user has full access to use any front panel object style because it is not going to affect the logic of your program. The logic is going to remain same, the functionality is going to remain same, but these object style, front panel object style only has different look related to the front panel. Let me show you in front panel. So this is like front panel. So this is front panel. When I right click it, now this is silver. And in silver I have various numeric controls and indicators. Similarly in modern I have various numeric control and indicator. This is system palette and this is classic palette. Thank you very much. In our next part we will discuss further about remaining uh, topics of lesson 1. Okay, thank you very much.